Welcome student in Christchurch Convent Digital Classes, subject Chemistry, class 11th. In this video we'll see about bond parameters. So if there is any bond between two atoms, it can be either covalent, van der Waals or ionic. The distance between two atoms from their center or the nuclei is called bond length. So what is bond length? As you can see in heading 4.3.1, what is bond length? Bond length is defined as the equilibrium distance between the nuclei. It is a plural of nucleus. Nuclei means more than two nucleus, two or more than two nucleus of two bonded atoms in a molecule. So how we can found bond length? Bond lengths are measured by spectroscopic method, X-ray diffraction method, electron diffraction technique, and these techniques are described in higher classes. So you will see in higher classes about these, what is spectroscopy and all that. So it is not in our syllabus. Each atom of the bonded pair means the electron pair which take part in the formation of bond are called bonded pair, contributes to the bond length. बॉन्ड लेंथ में उसका कुछ ना कुछ योगदान होता है या बंध की लंबाई. In these case, in the case of a covalent bond, the contribution from each atom is called the covalent radius of that atom. If there is a covalent bond between two atoms, then it is called covalent radius of the atom. So what is covalent radius? Covalent radius is measured approximately as the radius of an atom core which is in contact with the core of an adjacent atom in bonded situation. Means there is a covalent bond between those two atoms. The covalent radius is half of the distance between two similar atoms joined by a covalent bond. So bond length is generally measured in picometer, means 10 raised to power minus 12 meter. So it is a very small quantity or small length, as its unit is in picometer. So as you can see in the diagram in figure 4.1, there are two atoms, atom A and B, and the red line or dotted line shows the radius of atom A, and the blue line in dotted portion shows the radius of atom B. So they are respectively denoted by Ra and Rb. The bond length in a covalent molecule AB. So the bond length R is given by Ra plus Rb. So R is the bond length, capital R is the bond length, and small ra and small rb are the covalent radii of atom A and B respectively. So covalent bond in the same molecule. The van der Waals radius represent the overall size of the atom, which includes its valency shell in a non-bonded situation. So van der Waals are temporary bonds, and these are weak in nature, van der Waals bonds. But van der Waals radius represent the overall size of the atom, which include its valency shell also, but in a non-bonded condition, means the atom is free. So further, the van der Waals radius is half of the distance between two similar atoms in separate molecules in a solid. Covalent and van der Waals radii of chlorine are depicted in figure 4.2. So covalent radius of chlorine is 99 picometer and van der Waals radius is 180 picometer. So van der Waals radius are generally higher than covalent radius. So covalent and van der Waals radii in a chlorine molecule, the inner circles correspond to the size of chlorine atom, RVDV van der Waals radius and RC are the covalent radii respectively. Some typical average bond length for single, double and triple bond are shown in table 4.2. Bond length for some common molecules are given in table 4.3. So bond type, if there is a bond between oxygen and hydrogen, its covalent bond length is 96 picometer. And if there is a covalent bond between carbon and hydrogen, the bond length is 107 picometer. And if there is a covalent bond between nitrogen and oxygen, the bond length is 136 picometer, given on the right hand side of the table 4.2. And table 4.3 has some common molecules like H2. So hydrogen and hydrogen atom have one covalent bond and its bond length is 74 picometer. Between two fluorine atoms, the bond length is 144 picometer. Between two chlorine atoms, the bond length is 199 picometer, and so on. Now we will see about bond angle. What is bond angle? So it is defined as the angle between the orbitals containing bonding electron pair around the central atom in a molecule or complex ion. So we'll see what is central atom and complex ion. Bond angle is expressed in a degree which can be experimentally determined by a spectroscopic method. It gives some idea regarding the distribution of orbital around the central atom in a molecule or complex ion, and hence it helps us in determining its shape. For example, in water molecule, that is HOH, the central atom is oxygen, which can be represented as under. See, oxygen atom has 6 electrons in its outermost shell. So there are two non-bonded pair atom electron are present on oxygen atom and rest of the two electron will have covalent bond with two hydrogen atoms differently. So the non-bonded electron repel the bonded pair electron and the bond angle is reduces from 109 degree 28 minute to 104.5 degree. Now what is bond enthalpy or bond energy? Bond enthalpy is also known as bond energy. So what is bond energy? We will see in the next video what is bond energy.